Hey everyone, welcome back to the College Algebra playlist. In this video, we're talking about complex rational expressions, which are not to be confused with complex numbers. Okay, we're not talking about complex numbers or imaginary numbers in this playlist yet. That's a future topic. Okay, we'll talk about that later. In this video, we're just looking at complex rational expressions, and they're complex in the sense that they're complicated. Okay, because they involve rational expressions within rational expressions. Okay? Fractions within fractions. So that's why we use the word complex in this context, all right? So without further ado, let's just dive right into it. Okay, here we go. Simplifying complex rational expressions. The first thing we need to do is define what a complex rational expression is. Okay? A complex rational expression is a rational expression that contains additional rational expressions in the numerator, the denominator, or both. Okay? So it's fractions within fractions. That's what we're looking at here. Here are some examples of complex rational expressions. Okay? Here in black we have a divided by this whole thing, right? 1 over b plus c. And here in blue, we have y plus 1 over x, okay, and we're dividing that entire thing by x over y. And here in red, we have x over y minus y over x, right? That whole thing is being divided by y. Okay? So we can simplify these things and make them look nice, right? Because they're pretty messy right now. So make sure you stick around and watch to the end, because we're going to simplify all three of these. All right? But before we start simplifying, let's look at this recipe here, all right? We're cooking up some simplification, right? We're simplifying complex rational expressions, all right? Here's how to do it. Step 1, get a single rational expression in the numerator and or denominator, okay? Then we rewrite the problem using the division sign, right? Rational expressions are division problems, okay? And then we rewrite as multiplication, right? We multiply by the reciprocal. And then we multiply and simplify. Okay? So this is our recipe we're going to follow when we simplify complex rational expressions. All right? So let's try the first one. All right? In the denominator, right, we can see we have 1 over b plus c. All right? We need to turn that into a single rational expression. Okay? So, what do? I like to take the first step here and just rewrite c as c over 1. Okay, I like to do that because it makes it more clear that we're doing fraction addition down here. Okay? So 1 over b plus c over 1. We need to get a common denominator to add these fractions, all right? What's the LCD of b and 1? Right? It's the product, right? It's b times 1, so just b. All right, the common denominator we're looking for is b. Okay? So we're going to multiply c over 1 by a fraction equal to 1, right? And that fraction is b over b. Okay, that'll give us our common denominator. Okay? So when we multiply this black fraction by this blue fraction, right, we get CB over B. All right. Now we're ready to add these fractions because they have the same denominator, okay? So this is the part where we condense two fractions into one, right? We have 1 plus CB up top over that common denominator we found, B. All right? So we have A divided by this whole thing, all right? So let's write it that way. Okay, let's use the division sign to show what we're doing. Okay? When I divide A by this thing, right, that is the same thing as multiplying by the reciprocal of the second fraction, right? So we'll flip this fraction here, right? It turns into B over 1 plus CB, and it turns into a multiplication problem. And here I'm just rewriting A as A over 1, all right? Just to make it clear what we're doing, right? This is a fraction multiplication. All right? So when we multiply these fractions, right, we get AB up top, and then on the bottom we get 1 times 1 plus CB. Okay, so that's just 1 plus CB. All right. And this here, I don't know if it's been bothering you, but it's definitely been bothering me. We want to rewrite that as BC. All right. Put it in alphabetical order. That's purely a matter of preference. All right. You don't have to do that, but usually that's how we want to report our final answer. All right. So this big, messy, complex rational expression can be rewritten as AB over 1 plus BC. All right, something nice and clean. All right, so let's move to the next one. Here's the next example. Here we have y plus 1 over x, whole thing divided by x over y. All right, so we already have a single rational expression in the denominator. Okay, so we're good there, but we need to get one up top, right? We need to get one in this numerator. Right, so we need to add y plus 1x, plus 1 over x, right? So what we're going to do is rewrite y as y over 1, okay? This makes it clear what we're doing. All right, at this point, we need a common denominator, right? So we need to use the LCD of 1 and x, all right? And the LCD is just the product, x times 1, so it's x, okay? So we need an x in both denominators. All right, we already have it here. So to get it here, we'll multiply y over 1 by a fraction equal to 1, right here in blue, x over x. Okay? That'll give us yx over x plus 1 over x up top. Okay? So now we're ready to add the fractions in the numerator. All right, we get yx plus 1 over x. Okay? That whole thing is being divided by x over y. All right? So we'll rewrite this as a division problem, okay, just like before. All right, this is what we're doing. And then we'll rewrite that as a multiplication problem, right? We're multiplying by the reciprocal of this second fraction here, right? So we just flip it like that. Okay, let's take this to the top of the screen because we've run out of room here, okay? So we have yx plus 1 over x times y over x. All right. When we multiply that, we get yx plus 1 times y over x squared. All right. And this ordering is bothering me a little bit. All right, so we're going to swap the positions of these two factors. All right. We're used to seeing it like this, right, where the y is out front. Okay, so we have y times yx plus 1. All right, I can do that by the commutative property of multiplication. All right. And then here in parentheses, once again, we just want to write this in alphabetical order, right? Instead of yx, I'm going to write that as xy. All right, it's the same thing. So we can do that, no problem. All right, and this is our final answer. Okay, it can't be simplified any further. So let's move to our last problem. All right, here we have x over y minus y over x, whole thing divided by y. Okay? So we need a common denominator. We have y and x. All right, so we're going to take the LCD to be their product, xy. All right, so we need xy in both of these denominators. Okay? So let's do that now. All right, let's multiply x over y by this blue thing, and we'll multiply negative y over x by this blue thing. Okay? When we perform the fraction multiplication, right, we get x squared over xy, right, minus this result, right, y squared over xy. Okay? That whole thing is being divided by y. All right? So we got our common denominator, so we can condense two fractions into one, right? That's what happens when we add or subtract fractions. Okay, up top we have x squared minus y squared, and then on the bottom we have the common denominator of xy. Okay? So now we can rewrite this as a division problem, right? I have x squared minus y squared over xy divided by y. Okay, I'm writing it as y over 1. Okay? So let's change this into a multiplication problem, right? Let's multiply by the reciprocal, and this is what we get. Okay? And I've run out of room here, so let's take this to the top of the screen. Okay? Here's what we have. At this point, we just need to perform the fraction multiplication. All right? Up top, we have x squared minus y squared times 1. All right, so it's just itself. And down here, we have xy times y. That result is xy squared. Okay? The top is the difference of squares, right? It can be factored as x plus y times x minus y, like this. But we don't have to do that. Right? If we want, we can report this as our final answer or this as our final answer. It doesn't matter. All right? Either way, it can't be simplified any further. So that's what we have. All right? That does it for this video. Thank you for watching, and like and subscribe.